Welcome back. Let's suppose that we're told the point B is exactly in the middle of the line segment AC, and the distance of the segment AB equals 4 feet. We want to know the distance of the segment AC. Alright, so we're given this information and there's something that we need to find. We need to find the distance of the segment AC. So let's go ahead and draw a picture here to see what we're working with. So we have this line segment and it has the endpoints AC. It doesn't matter which one, direction really doesn't matter, but this is our line segment AC. And we know that right smack dab in the middle is the point B. And we're also told that the distance AB, this distance right here, is 4 feet. We want to know the total distance. We want to know the distance AC. So how are we going to do this? Well, we're told that by something called the segment addition postulate, that AB, the distance AB plus BC equals AC. So this segment, this distance of the segment right here, plus the distance of this segment equals the total distance. You might say that this is very, common sense. It's very intuitive, and it is. We just want to make sure that we understand the mechanics of the mathematics behind it, because we will actually be dealing with much of this throughout the geometry course. So this is called the segment addition postulate, that if we add the distance of this segment to the distance of this segment, we get the total distance. So we need to know what this distance is. And we actually know that because B is exactly in the middle of the points A and C. So we know that the distance between A and B is the same as the distance between B and C. So we can say that this distance is also 4 feet. And all we have left to do is plug these two distances into our segment addition postulate. So AB is 4 feet plus BC, which is 4 feet, equals AC. AC is what we want to find, and that's 8 feet. Okay, so this is called the segment addition postulate, and we want to get very familiar with it. We're going to use it a few more times. So let's go ahead and look at the next one. Let's say we're given another line segment. This is point X. We have a point here called Y, and I'm sorry, that's supposed to be a Y. This is point Y, and the other endpoint is point Z. We know that we're told that this distance here is a distance of 2 inches, and this distance right here is a distance of 7 inches. We want to know the distance of XZ. So we can use our segment addition postulate and plug these in and find the total distance. So we have 2 plus 7 equals 9, so the distance of XZ is 9 inches. 9 inches. Okay, very straightforward. Just want to get a little bit more practice. Let's take a look at the next segment. This is our next line segment. This point is point A. We have another point here, point B, and here's point C. This time we're told that the distance AB equals X, the distance BC equals 9, and the distance AC equals 12. We're not told the units here, so we won't bother with those, but we want to know, this time we're given the total distance, and we're given one of the segments, the distance of one of the segments. So we want to find the unknown. So we can use the segment addition postulate just the same as we have been, though we're just going to have to solve for an unknown, which we should be very familiar with that by now. So we have AB, which is X, plus BC, which is 9, equals 12. And if you went over the algebra course already, we should be very familiar with this. We can solve this simply by subtracting 9 from both sides. These two terms will cancel. That'll give us X is equal to 3. So the distance AB is 3 units. So we can use our segment addition postulate no matter how, as long as we're given 2 knowns, we can find one unknown. It doesn't matter which one is known and which one's unknown. We can find them just the same. So let's take a look at a different one. Let's say we have two coordinates. We have the coordinates 1, 4, and the coordinates of the point 1, minus 5. 1, minus 5. Okay, and we want to know the distance between these 2 points. Let's go ahead and draw our coordinate plane just to see what's going on here. Here's our x-axis, our y-axis, and our x-axis. We should be very good, very familiar with drawing axes by now if we went over our algebra course already. So this is 4, here's minus 5. Okay, so we have 2 points. We have point 1, 4, which is right here, and we have point 1, minus 5, which is right here. And we want to know the distance between these 2 points. So what are we really trying to find here? Well, there is a line segment. It's kind of imaginary, but there's a segment, a straight line that connects these 2 points. And when we're talking about the distance between these 2 points, we're talking about, we're talking about the distance of the segment, the distance of the line segment that connects these 2 points. And here we have a vertical line. We have a vertical line, we know that because the x values are the same. And when we have a vertical line, we can simply find the distance by subtracting the y values from each point. Now, when we're doing so, we want to use something that we learn in our algebra course called absolute value. So we want to put the absolute value bars around the subtraction of the y values. So 4 minus a minus 5, or vice versa. It doesn't actually matter which one you subtract from the other. As long as we have our absolute value bars, we're going to get a positive answer. And remember, actually, a positive answer is all we're worried about because it wouldn't make sense to have a negative distance here. We're always talking about positive distance. So if you recall from our algebra course, that absolute value is very closely related to distance. So we have these 2 negatives will cancel. So we have 4 plus 5, which is the absolute value of 9. And then we know that when we apply the absolute value bars, it turns whatever is inside positive. 9's already positive, so we just have a distance of 9 units. Okay, and you can actually see that this is indeed works out the same if we subtracted this point from this point. You can go ahead and do that, and we have the absolute value bars. We'll actually have a negative 9, but since we have the absolute value bars applied to it, it also becomes a positive 9. Very important that we get a positive answer when we're talking about distance. All right, let's. We have time to do a few more. Let's say we have the line segment AB, and we're told that the distance of this line segment is 4 inches. We're also told that the line segment BC is a distance of 6 inches. And we're also told that the points A, B, and C are collinear. All collinear means is that these 3 points all lie on one line. If we drew these 3 points, we can go ahead and do that. This is point A, this is point B, and this is point C. If these points are collinear, that means we can draw one straight line that will connect all 3 of these points. And this is very important because if these 3 points are collinear, that means they all lie on the same line, and that means, or the same line segment, and we can use the segment addition postulate to find whatever distance we're looking for. All right, so we're told that the distance AB is 4 inches, and the segment BC is 6 inches. And by the segment addition postulate, we can add 4 and 6 to get the distance AC. And this is actually 10 inches. Okay, now notice that if we weren't told that these points were collinear, the segment addition postulate couldn't be used, and it actually wouldn't. The segment AC we still could have a segment AC, but it wouldn't equal 10 inches. And we'll go over some strategies about how to solve that in a later video. All right, so these 3 points are collinear, and we can use the segment addition postulate to find whatever distance that we're looking for. All right, let's go ahead and squeeze in one more. We want to know that, let's say we have the absolute value of x minus y. And this equals the absolute value of y minus x. We want to know if this is true or false. And this is very interesting. Anytime we're talking about absolute values. This is actually going to be true. It's true because, let's say we know that x minus y equals minus y minus x. Okay, now even though this is true, whenever we apply the absolute value bars, that actually will make them both positive. All right, so since we have these absolute value bars, we saw this in just a previous example, that if we have the absolute value bars, it doesn't matter which one we subtract from the other, we're going to get the same answer. So even though that this is also true, if we put the absolute value bars around both of these expressions, we would get the absolute value of x minus y equals, well, the absolute value bars would kill this negative sign, so all we'd have is the absolute value of y minus x. That's actually what we have here, so we know that this is true. It's just a very quick proof using absolute value bars, and it proves what we learned just in a previous example, that we're talking about distance, and we use absolute value bars. It doesn't matter which point that we subtract from the other, it's actually still going to be the same. So very, very interesting. Go over this video a few more times. We're talking about segments and distance, and get very familiar with it. I'll see you soon.